Hello and welcome back. Today I'm going to show you how to build a super simple solar power system using just a few components, all of which are behind me. And this setup is perfect for anyone wanting to learn just some of the basics of solar power, charging small devices, maybe while you're camping, or even if you're doing homework in your backyard. It could eventually scale up into maybe getting started with some off-grid power systems. Before we get started, I just wanted to cover a quick safety note. Electricity can be dangerous. This is a relatively low voltage system that we'll be working with today, but batteries can still deliver some high currents. You might see some sparks, might cause burns if handled incorrectly. If you are doing this at home, always double check your wiring and use properly sized parts and follow any manufacturer's instructions for your specific components. This video is just for educational purposes. If you are unsure about any part of your own project, you should talk to somebody who knows the specifics before you move forward. So I'll start off today by talking about what is solar power exactly. Solar power works by converting the sun's energy directly into electricity. Inside of a solar panel like this one are photovoltaic cells. You might have heard of PV cells. When the sunlight hits these, it excites the electrons and creates an electrical current. This process produces DC or direct current electricity. One cool thing about solar power is once you've purchased and installed all the equipment, the sunlight itself is completely free. So some pros and cons of using solar power is the pros are it is a renewable energy source, and besides in the production of making these, for sure, there's no fuel cost in the collection and the use of solar power. It's very quiet because it's just the sun, and typically they can have very little maintenance and it can be super portable. You can scale the sizes really easily, and it can provide power in any sunny location from your backyard to a campsite. Some cons of solar power is all the components in the equipment can have a fairly high upfront cost. The solar panels can only produce the power when the sun is shining, so if it's rainy or if it's a bit cloudier, you're not going to get the same benefits as if it's sunny all the time. And batteries are essential for solar power systems. When it's collecting the power, it needs to be stored somewhere or used live, or else it's going to waste. So typically in large solar power systems, you do need large battery banks to store the power so you can use it when the sun is no longer shining. The three components in our solar system today is a solar panel, a battery, and then an inverter so we can use the power. To test to make sure everything works, I have a digital multimeter and my phone charger. So first, we'll go into detail on the solar panel. This is a 100-watt solar panel, and it is responsible for actually producing the electricity that comes from the sun. It is 100 watts under ideal conditions, though real-world output is typically not that due to clouds, shading, and they get a little dirty as well, and it will produce up to 12 volts of power. And now for the battery. We have this. This is a 12.8 volt lithium ion battery. It stores the energy that is produced by the solar panel so we can use it later. Lithium batteries are fairly new and becoming very popular because they're lightweight, despite what you saw of me just trying to pick it up. They're efficient and they can be discharged much deeper than traditional deep cycle batteries that you might find in a car. And we'll talk about the different battery types later in the video. Okay, so it's just balancing on there, but we have the red to the red, the black to the black, and we are reading about 12 volts. Let's hook up the solar panel, put it in the sun, and see if we can make it read higher. Like I mentioned before, the panel brings in power in DC, direct current, and that's also how it's stored in the battery. So if you're using a pronged plug like this, like the box to your phone charger or your laptop, you'll need something called AC, like you would find in your house wall outlet. And that's where the inverter comes in. This is a 400-watt inverter. And that means so you'll be able to connect devices that draw less than 400 watts, so things like your phone and your laptop will be fine. But if you want to start plugging in things like a hair dryer and a microwave, you might need to size up. So how it all comes together is that the solar panel will collect the power, which transfers it into the battery. It will be stored in the battery, both in the DC format, and then it will go to the inverter, which converts it to AC, and then eventually we'll be able to plug in our devices and charge them up. One thing I'm not using in this setup, because it is fairly low power and I know I'll be taking it down and putting it back up fairly frequently, is a charge controller. A charge controller sits between the solar panel and the battery, and its job is to safely regulate the charging process. Without a charge controller, and if you have a bigger system, the batteries could overcharge and become damaged. It's really important in larger systems. Oh, the sun's coming out. Really important in bigger systems, but since I'm using a small panel and just one panel, and not having it in the sun for too long, I'm not adding one to my system. But if you are upscaling your systems, be sure to look into charge controllers. So now you've been educated on what all the parts do, time to hook it together. The first piece to hook together is the solar panel to the battery. The solar panel comes with ends like this, and right now that is not very functional to get to our battery. So I also have purchased some attachments with clips on the end, and then I'll clip it onto the battery. And I'll set those attachments to the cable right now. There we go. Now we have our clips ready to attach to our battery. Okay, so when putting these together, there was only one way it would fit, so you do want to make sure the negatives to the negative and the positives to the positive, but there was no way to mess it up because it wouldn't have fit together. When you are attaching it to the battery, you want to do the same, connect the negative to the negative and the positive to the positive. Something happened with my wires where the colors are switched, so I put some tape on the ends and we'll go by that. That's why you want to be sure to double check all of your components before you start the project. This is my black clip, this is my red clip. I'm going to attach it to the battery now. Negative, negative, black clip. You want to make sure you get a good connection, a good bite. Kind of like if you were jump starting a car. Red, red, and there. We are officially charging our battery. Panel's turned backwards, so let's flip that around to get the most sun. Just like you charge your little portable chargers by plugging them into your house, this is our big portable charger, and we're charging it through the power of the sun. Okay, now we've got the solar panel hooked to the battery, which is charging up. We can now attach the inverter. So same thing, there's a negative and there's a positive, and you want to ensure that they are matching to the correct terminals. You want to get a solid clamp. just adjusting my solar panel clamps while I was in there too. And now we are ready to charge our devices. So, like I said before, if you want to use a block like this with a charger with prongs, you're going to need AC, and that's where the inverter comes in. The inverter has an on and off switch, but just to kind of show you the difference between the DC, which is automatically flowing through the system, you just need your regular USB end, and the inverter does not need to be turned on because everything is flowing in DC anyway. There we go. Setting, oh, that's text. And if I were to, without turning the inverter on, plug my phone into the brick and plug it into here, I'm getting nothing because the power has not been converted to AC, which the brick needs. So if I just switch the inverter on, I don't know if you can hear the fan noise. Boom. My phone lit up and it flashed that it was charging. So a lot of times you can just use this for your phones and you don't need the inverter to be switched on, which does draw power from the battery in excess of charging your phone. But laptops, things where it's all connected as one, that is where you'll need to be able to switch the inverter on. And it's just nice to have the options of doing both because you can get bricks like these and charge a lot of devices. So yeah, that's about all it takes to build your very own off-grid solar power system. That's super simple. You can get a smaller size of solar panel, so it's a lot more portable. It works great if you're spending a lot of time outdoors, and I truly would use these to do homework in my backyard when I was in engineering school, because sometimes it's just too nice to study inside, but your laptop needs to be charged. So I just want to talk a few things, especially about expanding your solar power system if you did want to make one bigger than this. So like I mentioned before, batteries are the key element to any solar power system that you want to be leaving up more permanently. There's two common ways to connect batteries. You might have heard these before, in parallel or in series. Parallel is where you connect the positive to positive, negative to negative. The voltage stays the same, but the capacity increases. So that means that if you had two 12-volt batteries like this in parallel, it remains at 12 volts, but you have twice the storage. And this is very common in smaller off-grid systems because that is your goal, is to increase your storage. In series, you'd connect positive to negative, and the voltages add together, but the capacity stays the same. So if you have two 12-volt batteries in series, you get a 24-volt battery bank. And this can reduce the current and improve efficiency, but it doesn't expand your storage. So research the type of ways that you want to expand your battery system for your own upgraded solar power system. Just going off on batteries, this is a lithium battery, and a lot of beginners, especially if you have the parts, you might wonder if you can just use an old car battery. And you definitely can. Car batteries do have a shorter lifespan in solar applications. They are more designed to have that initial pop for starting engines and don't like deep discharges, but you can use them for a simple solar power system versus the lithium battery, which is newer and I would say more recommended now. It has a higher usable capacity, longer lifespan, it's lighter weight, and it's designed for repeatedly charging and discharging, not just that kind of initial spark that you need to start a car, and overall better performance, but they do come with a higher price tag. The next way to expand your solar power system is to add more panels. That just makes you bring in more power as the sun is shining. So you can do this as your system grows, but again, this is coming back to that charge controller. Make sure that you do have a charge controller and that it can handle the increased voltage and current from your additional solar panels. If you want to see how the solar panel is charging your batteries, you can use a digital multimeter like this. We're going to switch it to, let's get in focus. 20 volts will work if the battery's lower, but we're just gonna bump it up to the 200 so we can get a full reading. And you wanna put the red pin to the red pin and the black to the black. Well, kind of funny, my camera just died as I'm building this solar powered charging system. I guess I'll have to plug it in after, but for now we're switching to the phone. And I've moved the solar panel so that it's in the sun a little bit more. So I have the red one pinned in there just to do this with one hand. I would recommend doing this with two. We got the black one down and we started at 12 and now we're at 12.1 volts, which is pretty good for a not particularly sunny day.